students, myself Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today in this unit, that is ODE of higher order, I will teach you a new topic, that is method of reduction of order. So let's start. This method, that is method of reduction of order, we have been given a one solution of second order homogeneous linear ordinary differential equation, and we will find out its second solution and general solution. Consider the second order differential equation, that is y double dash plus p of x y dash plus q of x y equals to 0. This is the second order homogeneous linear differential equation, and consider the one solution of this differential equation is y1. One solution of this differential equation is y1. Now we will find out its second solution and say that is y2. So how we will find out? And y2, that is equals to u y1, where u equals to integration 1 upon y1 square e raised to minus integration p of x dx dx. With the help of this formula, we will find out u, and then after, with the help of u, we will find out y2, and y2, that is equals to u y1. And the general solution y, that is c1 y1 plus c2 y2. Now we will see example related to this topic. You can see that if y1 equals to x is one solution of the differential equation x square y double dash plus xy dash minus y equals to 0, we have to find out its second solution and also the general solution. Here we have been given the one solution, that is y1 equals to x, and the given differential equation is x square y double dash plus xy dash minus y equals to 0. Now to convert this differential equation into the standard form, we will divide this whole equation by x square. So we have y double dash plus, if we will divide x by x square, you will get 1 upon x y dash minus 1 upon x square y equals to 0. Now we will compare this differential equation with the standard form, that is y double dash plus p of x y dash plus q of x y equals to 0. So by comparison, we have p of x equals to 1 upon x. Okay, now the second solution y2, that is u y1, and y1 equals to x, and p of x, that is 1 upon x. Now we will find out u, and what is u? U, that is equals to integration 1 upon y1 square e raised to minus integration p of x dx dx. Now this is equals to integration 1 upon, what is y1? That is x. So we have x square e raised to minus integration, what is p of x? That is 1 upon x. Now what is integration 1 upon x? So this one will be as it is, integration 1 upon x square. Now e raised to minus integration 1 upon x, that is log x dx. Now this is equals to integration 1 upon x square e raised to minus log x, that is e raised to log x raised to minus 1, right? Now what is e raised to log x raised to minus 1? If you will apply the property a raised to log y to base a, that is y. So we have e raised to log x raised to minus 1 on base e, right? That is x raised to minus 1. And x raised to minus 1, that is nothing but 1 upon x. So this is equals to integration 1 upon x square into 1 upon x. And x square into x, that is x cube, and we will write down 1 upon x cube as x raised to minus 3 dx. Now what is integration of x raised to minus 3? That is, according to the formula, integration x raised to n dx, that is equals to x raised to n plus 1 over n plus 1. So this is x raised to minus 3 plus 1, that is x raised to minus 2 divided by minus 2, right? So this is equals to writing x raised to minus 2 as 1 upon x square. So this is minus 1 over 2x square. Okay, so this is nothing but u, and we are interested in finding out the second solution, y2, that is equals to u by 1. So this is equals to, what is u? That is minus 1 over 2x square, and y1 is x. So 1 time x will cancel out. So we have minus 1 over 2x. So this is the second solution, y2. Now we will write down general solution y, that is equals to c1y1 plus c2y2, and c1 will be as it is, y1 is x, c2 will be as it is, and y2 is minus 1 upon 2x, so plus minus, that is minus. If you will multiply c2 by 1 over 2x, you will get c2 by 2x. So this is the general solution. Now we will see example number 2. If y1 equals to sin x upon x is one solution of xy double dash plus 2y dash plus xy equals to 0, find second solution. Also find general solution. Here one solution is given to us, and that is y1 equals to sin x upon x. Okay, and here the given differential equation is x y double dash plus 2y dash plus xy equals to 0. Now to convert this differential equation into the standard form, what we will do, we will just divide this whole equation by x. So we have y double dash plus 2 upon x y dash plus x upon x, that is 1, and no need to write down 1. So this is y, that is equals to 0. Now we will compare this differential equation with the standard form, that is y double dash plus p of xy dash plus q of xy equals to 0. So by comparison, we have p of x, that is equals to 2 upon x. And now we will find out y2, and y2, that is equals to u by 1. Now to find y2, we require u and y1, and y1 is given to us, that is sin x over x, and we will find u only. Now we will write down the formula of u, that is integration 1 upon y1 square e raised to minus integration px dx dx. Now, what is p of x and what is y1? Equals to integration 1 upon y1 square. Y1 is sin x by x, so square will become sin square x divided by x square, and I will write down divided by x square with the multiplication in the numerator, that is 1. So we have x square in the numerator, and then after e raised to minus integration, what is p of x? That is 2 upon x dx dx. Now we will find out the integration of 2 by x. So this is equals to integration x square upon sine square x multiplied by e raised to minus 2 will be as it is, and integration of 1 upon x, that is log x. Okay, this is equals to integration x square over sine square x. Now we will write down e raised to minus 2 log x as e raised to log x raised to minus 2, and the base is e. Now we will apply the formula of a raised to log y to base a, that is nothing but y. So e raised to log x raised to minus 2 to base e, that is nothing but x raised to minus 2. And we will write down x raised to minus 2 as 1 upon x square. So this is equals to integration x square over sine square x multiplied by 1 upon x square dx. So x square will cancel out, and 1 upon sine square x, that is cos x square x dx. And what is integration of cos x square x? That is minus cot x, right? So this is nothing but u, but we are interested in finding out y2, and y2 is u into y1, and u is minus cot x, and y1 is sin x upon x. We will write down minus cot x as minus cos x over sin x into sin x over x. So sin x will cancel out, and this is equals to minus cos x over x. So the second solution y2, that is minus cos x over x. So now we will write down the general solution y, that is c1 y1 plus c2 y2, and this is equals to c1 y1 is sine x upon x, plus if we multiply plus sign by minus sign, you will get minus sign. C2 y2 is minus cos x over x, and already I have multiplied this minus sign with this plus sign, so we have C2 cos x over x. So the required general solution y is C1 sin x over x minus C2 cos x over x. So in today's lecture we have seen method of reduction of order, and in this method we have seen how to find out y2 of second order linear ordinary differential equation if its one solution y1 is given to us, and we have gone through two examples based on this topic. Thank you for watching this video.